Welcome everyone to the second in our June series on Getting Practical with MBSE, Collaborative Model-Based System Engineering, presented by Fran McCafferty. My name is Donna Long and I will be your host during today's webinar. Fran is a practicing principal systems engineer, leveraging experience gained over a 30-year career. Fran was one of the early pioneers in applying model-based systems engineering, serving as the GE-era Strategic Defense Initiative Requirements Manager. He has also led numerous project architecture development efforts for commercial, U.S., and foreign defense projects. Before Fran gets started, I have a few housekeeping items. We will be answering questions at the end of the webinar. Please send your questions in as soon as you think of them through the Question tab on the webinar control panel. Fran will answer as many questions as he can today, but if we do not get to your question, we will reach out to you after the webinar. The webinar is being recorded. If you experience connection problems during the live presentation, a recording will be available within 1 business day. The recording will be published to Vitek's Webinar Archive, located on our website. At the conclusion of this webinar, our survey will open on your screen. Please take a moment to give us feedback on today's presentation or on what topics you would like to see covered in future webinars. Now I'm going to turn the presentation over to Fran. Welcome, and thank you for joining us.
Good morning, everyone, and thanks for joining me on today's webinar on collaborative model-based system engineering. Donna gave you a little bit of my background. I'm not only a practitioner of systems engineering, but I also really enjoy doing it, love working with models and developing high-quality designs. So let's start into the webinar this morning. So what I'm going to do is, and I hope you'll indulge me for about 5 minutes. I promise not to do death by PowerPoint. It'll be about 5 minutes and 5 minutes only. So what I'm going to do this morning is lay out the groundwork of how GENESYS works. What's the environment that we've developed? How do you capture your models? How do you present your information? I'm going to go into a brief discussion of what we call the ERA, Elements, Relationships, and Attributes. That's how our data is organized. And a key feature of our design paradigm is that information exists in the database exactly once. So any changes that are made to multiple views, they all roll back. I'm also going to show you a whole series of integration steps that allow you to have an end-to-end engineering environment focused on system engineering. We know that people use lots of different tools to communicate their ideas, and we want to make that as easy as possible. So we'll show you those integration points. And as an advertisement for next webinar, my colleague Ron Kratzky is going to go into a detail on constraint resolving using a MATLAB connector. I have the connection today, but we'll leave that up to Ron for next week. With any engineering environment design, it's critical that we maintain control, configuration management of our systems. I will take a brief represent what's going on in permissions, how to check information in and out, how to collaborate, how to protect your information, to understand the audit trail and revision control. So one of the keys that we understand from system engineering is that we've got to be able to communicate. Our primary product is information. We have to get information from people, and we've got to distribute information in terms that people can understand and to use. What I'm going to show you coming up is how all that information is assimilated, analyzed, and then redistributed inside of our environment. And one of the emphasis points is that we can do much of the integration inside of our GENESYS design environment, that we don't have to go from one tool suite to another. Granted, there's lots of available tools that folks can use, but the simplicity, the consistency that we have in GENESYS, we think makes it easier for system engineers to do the work that's in front of them. So again, what the customer we always look at as the primary stakeholder in any organization. We gather their requirements, we model them, and we simulate them. But there's also another set of people in the community who are also stakeholders. For instance, the user. Very often in designs, that user community is as an afterthought, and the system doesn't work exactly the way they would want it to behave. We have subsource matter experts. These are the folks that we need to have weigh in to give us their insights, how to manufacture something, how to package it, how to move it throughout the logistics streams. So we've got to give them information in terms they can use and understand without becoming full-fledged tool or system engineering experts. Our own organization may have objectives for our products under design. So we want to gather those and make sure that that stakeholder community is serviced. And then there's us. We are the system engineers. We're the great communicators. We tie all these things together and we work in distributed environments. We want to be able to get the information in and out into our single database. On the right-hand side, you see that I have two different graphics, an engineering view. What I'm going to show you coming out of GENESYS are a whole series of engineering views that allow you to communicate with people the way they want to be communicated. We also generate a whole series of specifications. It's important to understand that we don't engineer our specifications. We generate specifications from our engineering. So it's a dynamic environment that makes it easier for us to get our information out to the user community. The GENESYS design environment is a single integrated repository. There's exactly one source of truth for our design. From that, we put information in to perform our analysis, and we generate the outputs that are consistent. If a change to any single view of our system is automatically represented throughout the entire system. So when we perform our engineering analysis, our system segment specs or our interface requirement specs can be automatically generated. Inside of our environment, it's not just text editing and graphics representation. We're performing a full-fledged series of engineering, modeling, simulation, analysis that all gets captured inside of the GENESYS repository. That information is not located in a single computer. We can have that distributed to the extended environment, but it maintains consistency throughout the entire cycle. So here's a representation. We understand that people have other products and tools they want to use. What I'm going to show you is that we can have the information represented in your terms. The system engineer can look at the information, decide on what views to make, what edits to organize, and then publish to the rest of the community. So we can go through whatever interface because of our open architecture. We can interconnect with other products. And again, I'm going to show you some of the examples today that we have a direct connection into DOORS, which many people are using for their requirements management, and then into Microsoft Office. There's lots of different applications inside of there, and we've got productized, commercialized connectors that allow you to get information into PowerPoint, Excel, Word, and Project. So I'm going to go off into our tool for a second, and for folks who are familiar with how GENESYS works, I apologize, but I want to level set so everybody understands how we can work inside of the tool space. So if you give me a second, please. What you're looking at right now is what we refer to as the Project Explorer. In the introduction, I explained to folks that we have an ERA, Elements, Relationships, Attributes model that controls how the information traverses inside the system. The data exists exactly once, but it's interrelated and allows us to dynamically generate a whole array of views. So let's look at what we have here. On the left-hand panel, hopefully you can see my mouse, is a listing of the elements. Think of those as engineering concepts. Those are the classes of things that we are going to do as system engineers. When we select any specific representation of an element, then we get all the instances that are being represented. So I've selected the requirement element class, and then what's populated are all the instances of that class. The next pane that I want to talk about is the property sheet. With any element that's populated, we have a series of the predefined attributes that you as the engineer have the option to populate or not populate. There's no requirement that all the attributes are populated. That's completely up to you. Our consistency checkers will go through and tell you which ones have been and which ones have not been populated at your discretion. Now, on the bottom pane, I'm showing are the relationships from one element to another element. What are the relationships? And it's a natural language, so it's easier for the human being to understand what I'm going to do. It makes sense logically as well as in the textual context. When I select any of the relationships, it shows me the target instance that is satisfied by that relationship. And in addition to attributes on the overall element instance, I can also have attributes on relationships. So this was the overview of our Project Explorer. Now what I'd like to show you is how the views are going to come through and represent the information in a graphical context. So what I'm going to do now is I'm going to select the requirement element class, and I'm going to choose a specific instance. In this case, I'm going to select requirement R2, and that is the specific requirement. So you notice that the attributes dynamically change. It's context specific, whatever's highlighted, and it gives you the up to the second representation. So what I'm going to do next is I'm going to select over into the views. And what I'd like to show you is that I have a hierarchy dynamic generation. And I do have some of these views populated, so it's as quickly, I can present them as quickly as possible. On this requirements view, you see that I have my starting point, R2. Then I have the next layer of requirements broken out below it. And you notice that we're calling out different attributes that are populated on the screen. So you are able to see very rapidly what the relationship of a particular requirement in this instance is to the rest of the design repository. An important aspect of these diagrams is that if there's a change or there's an impact that you want to analyze, you can quickly and graphically understand what those changes might be and what the scope of the impact is. It's not just a blind textual reading. So this is the requirements. And you do have the ability to dynamically click on any one of them, open up its property sheet, and follow the relationships there as well. Now what I'd like to do is show you another area of interest. I think this is the function. Functions are telling us what the system has to do, and we are going to walk through and show what the functionalities are, what the information traverses are, and what the control structures are that are associated. So I'm going to select a specific function. Again, I've got the element class, the instances, we see the attributes, and in this situation, what I want to do is I want to open up a SysML rendering of the system, and it's an activity diagram. And I want to point out that we fully modeled the SysML graphics environment. We have a whole series of views for folks to use, but a caution is SysML is an excellent view of your engineering. It's not the actual engineering. The engineering takes place inside of the model, and we generate the views that support or communicate those ideas. So on this panel that I've just posted, you see an activity diagram of our context function. We have the control structures on the left, the larger ovals are the functions, and in between we have items that are going between functions that are acting as triggers and as data sources. But that's only one representation. Other folks may want to see things like a sequence diagram. So a sequence diagram is showing what the swim lanes are. At the top I have a series of components and then the functions that are tied to it. And these diagrams are not just independent views, they're intimately tied to one another. You can't make a change on one without the other being affected. So let's go through and do an example of that and show you how that takes place. So if you will, I'm going to select a particular function represented by the oblong oval and a second, and I'm going to connect those two things. So what happens next is I'm posting and it's asking me context-specific information that says I want to know what the connection is between these two functions. I'm going to create a new one and just call it new demo item. Now watch your screen. When I click through and apply that change, we have two things that took place. One was on the sequence diagram, I now have a new item that's presented. Let me slide this around so you can see a little bit better. We have our new demo item that I just created, but also on a seemingly non-connected view, I have a separate connection that's being shown on that second view. It's the same item, it goes between the same functions. This is a dynamic rendering of it, so that you see that if you make a change in one view of our information, it dynamically populates. So let's go back to the activity diagram. If I were to delete this item, watch what will happen on the activity diagram. All the references to it are removed dynamically at the exact same time. So this is part of our functionality modeling, and I made a point of showing you how all the views are connected. The next thing I'd like to show you is the physical concept, how we're going to model hardware, software, interfaces, and the like inside of the product. And we categorize that as a component. Once again, we have an element name on the left-hand panel, And context specifically, we're going to pick out what the components are. Now, I'd like to point out that there's always at least 3 ways of getting to the information you're looking to work on. My colleague Donna, who you heard do the introduction, says there's probably 5. So what I'm going to show you here across the top is these are a context-specific listing of what's available based on your selection. So these are components, and these are the views that are associated with it. I also have the ability to do the same thing on the bottom here, that I can show hierarchy views, and it's just a peg through where everything's integrated inside the Project Explorer. So I can show those as well. I can show an interface block diagram. And notice that this diagram allows us to integrate cartoons, icons, graphics, and annotations so that it gives the information in a more user-friendly fashion so that people can understand what it is. This particular diagram is showing that I have internal and external components, and then I have linkages between any 2 of them. So those are represented by the names. And you can dynamically change what these icons look like. It's up to you if you want to generate them or use them from a stock image grouping. So let's go through and take a look at what we can do with our views. So a second way of getting to the information is I open an entity. When I open the entity, I'm going to select a physical block diagram. So on the physical block diagram, that's what we were just showing, and you can move the icons around if you so choose. Depends on how you want to organize your information. So we're tying that together. What I'd like to do next, and this is the hierarchy. We can have the different breakdowns of how the system is going to be organized. And this is an important analysis point because people often aren't sure how to partition their system. Well, inside of GENESYS, you're able to do an analysis of alternatives and look at different partitioning strategies to see which one is the best for your organization, for your product. So I'm going to go through just running through a quick hierarchy view. I can go through and see how this system is broken down. And I have my context, I have the human customer, external systems like a satellite. I have services that are external to my system under design. And then I have my system under design, and I've broken that down to a second layer, which includes a command center and a workstation. I'm going to take us back into the requirements domain for a second, if you will. So I'm showing you inside of GENESYS that we have a single integrated repository, one source of truth. So all the people that are involved have the ability to go through and look at the information and based on what you're interested in as an organization, who has access rights to the information, who may update and populate it. What we're showing is that all this information is intimately related. I have hierarchies of requirements. A requirement is the whole reason why a function exists. So I have a function in my hierarchy that is directly related to the requirement through a specifies relationship. Well, as a subcomputer designer or subsystem designer, I'm going to derive requirement or functionality to a lower level or a higher level of detail. The existence of that function now causes me to generate derived requirements. Those functions then are intimately related to the physical hardware or the software. So I will allocate functions over to the architecture that shows that I have my dimensional analysis complete there. And then we're never done until the testing is complete. Inside of GENESYS, we can track how the requirements are modeled, simulated, and then validated and tested through relationships as well. So that we run the spectrum of from inception through completion in our analyses. Something I think that sets us out is that we integrate the capture of risks, the analysis of risks, and decisions that are made in your development directly inside of the model. All too often organizations change staff or a system's been fielded for a long time and people are no longer available to work on it, and we don't know what they did. Because of things inside of GENESYS, we can directly relate why the decisions were made at a particular time in history and associate that so that we've learned and have that lessons learned database at our fingertips. So let me go back into GENESYS for a second here, and because I want to show you how we can go back into the requirements element class, specifies requirements, and in this case, I want to open up that view once again that shows the hierarchy. And you'll notice that I'm capturing different icons, and I can color code these concepts to make it bring it out clearer to the consumer of the information. So I've got a requirements decomposition, and because of a requirement, I have an existence of the geospatial library. While I was doing the analysis of it, I determined that there was a risk, and that was associated with the number of people that were going to work on a particular shift. We don't know. It may be fine, it may not, but it was an element of something that had to be considered as part of our design. So we institutionalized these graphics such that you can see what's going on. The concern, in my view of it, is it's an action item. I've got something I have to do that's going to make my design tie together better, quicker, faster, cheaper, something I want to pay particular attention to. So I'm showing you that you've got your requirements, and those tie into functions and into the architecture. And if you look further, you see a function is also allocated to the component. So we're tying those different domains together in a single integrated environment. There's no need to pour it off into another tool to worry about interfaces from product to product that may or may not have been designed to work together. So to me, this is a more streamlined, more consistent, more concise design environment. In the introduction, I pointed out that there's areas where we want to understand who's making changes to our system. Why are they doing it? How are they doing it? And what's the impact onto my system? So what I'm going to look at here is I'm going to choose set permissions here. And this is an important concept because we have different classes of users that need information, but we want to make sure we protect them from themselves as well as we want to protect ourselves from inadvertent changes. So inside of GENESYS, we can create classes of users and associate those classes of users to permissions that are available. So here I am, I'm Fran, I have a read-write permission. I've actually given myself administrator privileges for obvious reasons, but I'm going to go through and say what I'm allowed to do, what elements I'm allowed to view, which I'm allowed to make edits to, some I'm allowed to delete. And this is important for a distributed environment. We may have more than just one organization that's participating in our design that it's critical. So we can give them the information that drives out the context for their design and maintain the portions of the design that are critical into our control spaces. So we can grant those throughout the system. Another area that I'd like to point out is I have that specific requirement opened up. If you look on the right-hand side, I have a version icon. And what this does for me is it gives me an audit trail of who has done what over time to that specific attribute. So we can control entire baselines, we can control instances, and we can control versioning so we know exactly what happened. So if we select on a particular instance, we can go through and restore to a point in history what somebody has done. So you have complete audit trail history of your design. Additionally, we have an audit trail log that goes through and tells you what was done by whom and how it was performed as well. So you have that fully expanded audit trail and information set. So what I'd like to do next is I went through and I showed you how information was captured, how you can model it, how you can view it in different diagrams. And now the next step is we've talked about stakeholders and involving all those stakeholders into our design. So what I'm going to do next is I'm going to show you that there's a connection or automatically built inside of GENESYS such that for DOORS users we can move data back and forth. It's trivially easy. That's a connection. We capture things like the DOORS unique information so that relationship is established and maintained throughout the life cycle. So it's as simple as pushing an import-export button, which direction I want the information to move. MATLAB's over here. I promised you that would be Ron Kratzky next week. So let's just do a quick export. What's happening is I have my connection. It's a productized interface. I type in, 1 second, my login and password. Because I'm Fran, it's going through and it's making the connection to DOORS. And what it'll do is it'll get the information so that it's a two-way connection. So it'll ask me which module, because DOORS can have multiple modules, and I can just click on next. It'll ask me a package. For expediency purposes, I'm going to now go into my DOORS, and I'll show you things. For instance, here's the requirements that were ported across. So it's a two-way modification possibility based on permissions based on authorization. So it's trivially easy to move data across and to connect to multiple databases from that matter as well. So you can see how that's performed. And I was showing you on this particular diagram that there are packages we can bundle up. Only specific information is moved from one place to another. So I'm going to close out of that. Now probably the most used engineering tool in the world is Excel. We as engineers love our spreadsheets. We like to have the information and be able to massage it and organize it, rank it, do statistics and parameters and parameterization of it. So what I'm doing is I'm opening up Excel. Now this represents a distributed user base. Anyone with Excel has access to the information through the GENESYS Excel connector. Now I'm going to log out, and I'll show you how easy it is to make the connection. I log in. There's the username Fran once again. Type in my password, and I make my connection. So what I'll do next is I've called out which repository I'm connected to. I can also show which parts of the database I'm interested in moving over into DOORS. And in this situation, I'm just going to hit the load button. It's going to go back into my repository, grab the information, and put it into a spreadsheet. Now I'm just giving it a second to go through. And the first thing that shows up is a dashboard of statistics, and that's context specific as well. I can use the other facilities to give me the graphics I want. But that's an overall summary diagram, which I've used things like this for preparation for major milestone reviews. The next piece I want to do is be able to show what data is going to come through. So this is the posting of the productized interface. I'm able to go through and say, I'd like a particular query to be executed from GENESYS, and that information be moved over into DOORS. So what comes out on the bottom is the rule set that's saying, hey, these are the things I want to see in my spreadsheet. So I've got an attribute that's number, I have another for name, type, description, and then if I have recursive or some relationships, I can define what relationships are going to take place too. So I simply select the load button, and it'll bring that data over, and you can see it dynamically populating as we go. So now, the question should be, is this a two-way interface? And the answer is yes. It's dynamic. I have to do a push-pull kind of operation to get the information to move, but I could have this distributed to any user who has Excel. So what I'd like to do is I'm going to give you an example of a particular requirement. So here's requirement R212, customer, certify customers, and it says the system shall certify customers. If I'm back into GENESYS, I can show you very quickly. Certify customers has its series of attributes, and I want to scroll up so I can see the description, and then go back into Excel, and here what I'm going to do is I'm going to make a change to, and call that TBD. So what I want you to see is once I click out of the cell, it's highlighted as yellow, so you can clearly see what's going to be modified inside of the system. So what I'll do is I push the publish change, and that information is going to roll right back into GENESYS so that you can see the information. And now it says to standard TBD. So once I push that execute button, that information is moved back and forth. So I can do this through multiple people. I can allow it just to be on a small subset or on a grander project basis. So that's a commercialized interface to Excel. During the demonstration, I showed you a whole series of really cool diagrams that were built by the data that was inside of our design repository. So that's great, but now when I have a major review and I want to communicate the ideas, I want to be able to get that information into things like PowerPoint, so I have my slide decks available. Same kind of concept. I have a productized connection to PowerPoint. I'm logged in. I'm saying that I would like to use the functions that are in my system, and I get to choose what kind of view I have. On the right-hand side, lets me pick dynamically if I want more than one element class, what kinds of views I want to have, and all I have to do is push the insert button. And what you're going to see is the views are being extracted from the database and dynamically placed into the PowerPoint. And you should see that these are the similar views of what you saw earlier. It's the same information, and it's a snapshot view. I'd also like to show you how we can move the information back and forth into projects. Program managers are involved with our systems as well. It's important that we have tasks, activities designed such that we know when we're going to do which parts of the functionality. Productized interface, once again, I'm already logged in. I'm looking at the program elements, and I simply press the load button, and it's going to go into those element classes and pull the information into Microsoft Project. And I'm just giving it a second to load. I only have a small subset, so you wouldn't have to wait very long. So I have different tasks inside, and if I so choose, I can change my orientation. This concept is we call facilities, and facilities makes it such that you only see the information that's really pertinent to what you're working on. So I can go to program management, and I can see the tasks that that I've just moved back and forth between Microsoft Project. I'd like to also show you some of the outputs. We talked about being able to share information. We as system engineers are the communicators. We need to generate specifications such that people can actually understand what they are. We use a scripting language that allows you to get the information. You can dynamically select what parts are included, what are not. So what I'd like to show you first is what we call it's our team view. And this is an important concept because this is a read-only environment. We generate the report, publish it out to some shared drive, to the internet, whatever that may be for your environment, and allows your users to look at the information, and it can walk the relationships, but only in a view mode so that it's protected against inadvertent changes. So for instance, I have the function element class selected, and I picked, I double picked, I picked the perform system context. The first thing you see is that I have a property sheet, but I can just as easily click over and say I'd like to see an enhanced functional block diagram. And this is one of our views, and you get to see what triggers look like so that things stand out more clearly for you. And from there, you're able to walk other relationships to see the information there as well. So it's a hyperlinked dynamic environment. We have organizations that publish it periodically, whether it's by the day, by the week, by the month, and then push it out to some shared drive for whomever to see the information. I'd like to show you a couple other standard views. We can generate specifications in the form and format you want. We've got a series of predetermined ones that make it easy. The one I have open is a system description document, and I've called it DOORS connector because I wanted to make sure that I had that interface partitioned inside of here. And as you can see, it's a pretty significant document, and it's based on our geospatial library. And some folks don't care for it a whole lot because it's pre-canned, but it gets the information across as it's a technical environment. So if I scroll through, you can see that the diagrams are included, the textual relationships and descriptions are involved, and it's a very quick design engineering environment for you to see and bring your data together. I'd like to show you another area to bring information. If you give me a second here. This is a table maker. So I went through and pre-positioned the information, but I went through and I selected that I wanted to have a 4-column table generated that I could use in another context. So it gives me the information tabularized that I can see it and then be able to perform things in say, a Microsoft Word, or in this particular situation, PDF. So you can get the information out as you see fit. So that's going through and just showing you some examples of how that pulls together. How do you get the information out? How you get it to distribute? You could email this file to whomever, generated automatically by the GENESYS repository. So I'd like to go back into my presentation for just a second. So we talked about how the information traverses, how I'm developing requirements analysis, and those things are tied, how the functional analysis is associated with the requirements and allocated to the architecture. Because GENESYS is a full-fledged design engineering environment that lets you capture your thoughts for posterity and then be able to communicate the views. So for any user, what I'm representing here is a stylized representation of the ERA. Lots of time was spent developing the elements, relationships, and attributes to prevent people from making inadvertent mistakes. The language is rather clear. It tells you how to move data between element classes so that the information does maintain the consistency. And this is a representation. We looked at functions represented here and how they're associated with requirements. Requirements also drive out that we have physical architecture or components, and then that we have functions that are associated, allocated directly to that component. So we're making that end-to-end tie, that end-to-end relationship. So I want to wrap up the presentation component of our discussions and give you the opportunity to ask questions in a second. But I do want to emphasize that when you're using model-based system engineering implemented in GENESYS, that it's a real-time collaboration. You can have multiple people working on the database at exactly the same time. They can make their modifications, and then it's instantly available to any of the consumption side of our groups. We can see how those changes are impacted, how they roll into our design. And it is real time. It's not an extensive delay lag type of environment. There exists a single source of truth. During the demonstration, I showed you that if I made a change to a sequence diagram, by putting on an item, it was dynamically represented on the activity diagram. And then when I removed it, the other diagrams were referenced immediately as well. So we only have a single source of truth, and that's important. Like from my experience, when we would have a change ripple out, we would change the system segment specification, and then there were a whole series of interfaces. And if you were actually on the lucky side, all those changes rolled all the way through. But there was always the possibility that you forgot something. Not that you were careless, it's just there was a large volume of information. With our complex systems today, you really need that single source of truth to get the information into a single area that you know what the impacts of changes are, so that you can cost them, you can determine what the impact of schedules are, and then roll that back into your project. We have commercialized interfaces that are robust and get that information to the consumers. A reference that in Excel, everybody seems to have Excel in their engineering environment. We can move the information over to them. You don't want to require everyone to become a GENESYS expert. So we want to give information in terms that people understand that they can use the data the way they want to use it. A key for the system engineering is that it's not about what we want to show, it's about how they can understand the information and get it, they can consume that data in the most efficient way. Everything we do is data driven. So when we look at the views, it's based on the definition of the data. It changes to the data, change the views throughout the entire system. And we have the configuration control that's critical for the success of any project. I showed you during the demonstration that you're able to make the change. You can see it on the attribute level. I can do an entire design baseline configuration setup so that nobody can change things that have been approved by the higher sources, and that you can see the changes by who did it, what time, and if you have a need to, you can revert out of that rather easily without having an enormous IT type of operation to revert your files. And it's instantaneous that everybody can see it. So I'm right up around my time frame, and what I would like to do is open up for questions if anybody has anything they'd like to ask. Donna?
Thank you, Fran. We do have a few questions, thanks to all our participants. I encourage you to join the discussion now and submit your questions using the webinar control panel. If you do need to leave the webinar, please take a moment before you go to respond to the quick survey that will pop up on your screen. Our first question you just answered, but I wanted to make sure that you that Hans was aware. Hans asked how to prevent concurrent editing when working in an Excel export.
You can't completely prevent, if you have two instances of the file, what will happen is the last import will be the edit. We will have a tracking of all the changes that were made, but the last one in, if everybody's authorized to make the changes, that last import is the one that will be represented as click-throughs. The other ones you'd have to look at the audit trail.
Okay, thank you, Fran. The next question is, does GENESYS support the use of ontologies to support reuse of external knowledge? And that's also from Hans.
Okay. I will plead a little ignorance that I don't understand what ontology is, but if I can make an assumption, you are able to use archives of designs in a modular fashion. GENESYS is an open architecture that lets you have hierarchies of design. So if there were parts, components, software modules, those can be reused inside of your model. Those can be brought in and extracted for future use. Again, I apologize, I'm not familiar with ontology.
Okay. Let's see, can you lock a group, this is from Carrie, can you lock a group of objects to prevent someone else from editing?
Carrie, that is an absolutely true statement. As the administrator, you generally have access to the entire repository. From the systems perspective, if I'm at a system of systems, I may control what functions, requirements, interfaces, components that are associated with the system level. I then have my detailed design teams that are going to work on subsystem A, B, C. Those may be individual teams. I can create user groups and specific users who can work in those subsystems. As an example, they have view into the system level of the design. They have view into the adjacent subsystems, but the only area they're authorized to manipulate are those things that have been assigned to them. And it will be based on the group and or the user depending on the project and how you want to set it up.
Okay. The next question is from William. Can you provide the full GENESYS modeling schema metamodel to show the relationship of all the modeling elements and supporting views?
For folks who have demonstration licenses, directly inside of GENESYS, we have a script that goes through and it's a schema definition report. That schema definition report gives you a full layout of all the element classes, all the available relationships for that particular class, the attributes, what the intended use of those attributes are, as well as the attributes on the relationships. It's a multi-hundred-page document that goes through and tells you how that information is oriented and orchestrated. And just as a quick aside, the ERA has many, many years of research and operational analysis that goes into defining what that ERA is. It's set up so that it prevents you or greatly diminishes the ability of people to do inadvertent things with the system. It keeps it tied and consistent so that all users look at the information and can traverse and understand how the information interacts with each other. Hopefully I answered the question there.
And don't forget about the system definition guide and the architecture definition guide. Those will also help focus in on the modeling aspects of the schemas. Is there a way to filter the representation by risks, functions, components? This is Jose.
Jose, absolutely. During I gave a graphical representation. I did not show the risk element, but if we can diverge back in for just a second, I can show you that we have risk elements inside of the system. I filtered on program management, so I can shift it over to my system engineering because that tends to be where I work. And then we have a risk element. So for instance, I showed you the icon for a risk of the staff. It's an element class inside the system and it has its own attributes. I can generate queries, different hierarchies that are using this as a, let's see what we come up with. I'm dynamically doing, so there's always the concern I might mess something up. But I can look at the risk and show that, well, in this case I didn't look at the right number. I can see that there are different relationships to the risk, what requirement that risk is tied to, if it's tied to a function or a component. I can do a query dynamically and evaluate what is the origin of that risk. And like for instance, if you're looking on it, you get to see the status. It's unanalyzed, it's unmitigated. What is the mitigation plan? And we can put values against it for cost factors. And then we can generate the most folks like to use the stoplight chart where it's showing whether it's a high likelihood and a high impact. We can generate those reports dynamically from the database.
Okay, Jose put a clarifying question in. He did see that, but I was wondering if for presentation purposes, can I hide filter by what I want to show to management?
I think I understand what he's asking, and the answer is yes. You can select what's going to be, if I understand correctly, I can create a package that restricts what's going to be viewed in any particular report, and I can report on that package. So I can move a set of risks, maybe not all of the risks. Ones that are in the formative phases I may not want to expose to my senior management at that moment, but I want to have other risks that are more mature, we fully understand them and are in the mitigation process. So you are able to organize the information and only show what you're interested in showing.
He says thank you. That answers the question. Okay, another question from Eduardo is to allow the dynamic links. Do you save the commercialized interface documents within the GENESYS database?
The database has the entire design history inside of it. We store the information in a SQL database, and revisions are captured as updates. If you're sending information out to other folks, it's just a representation of the data. If you wanted to keep a specific versioning of the Excel, I'm making an assumption that you would probably want to do that in your external world, but you could recreate it from inside of GENESYS by applying different filters. Now, if you had a baseline, for instance, if you baselined a report, the information that's associated with that baseline would be regeneratable, if that's a word.
I'm not sure if it is or not. Here's another question from Hans. How does GENESYS relate to generic PLM systems?
Can you explain what the PLM acronyms?
He gave an example of PTC Windchill. And okay.
Well, Windchill it captures information as well. I've used Windchill in past lives, and you're capturing the data inside of it. If there were a need, you could archive views over into something like Windchill. I think that our design environment is superior because I can associate things like Pro-E mechanical drawings to a specific component, so I can see what the relationships are in a graphical or in a detailed model view versus the system view of what a particular design looks like. I can also associate that with electrical design vehicles or software environment. So I have a representation. I can associate external files that are important to the design with the element of interest. So if you were to choose to move things over to Windchill, that would be at your discretion. I think that our environment does many of the same things, and from my experience, I think it does it better than what I see in Windchill. But that's opinion. We're all entitled to our opinions. Others, Donna?
We have other questions, yes. Does GENESYS have interface to standard CAD tools, e.g. for drawings, export views of model, 3D PDF, etc.?
Mainly what I see when I'm drawing from my experience and how I would use it. There's always the implementation aspect of things. For a 3D modeler to know what they're modeling, they need the requirements that are associated with it. So from that context, we're storing the information into the SQL database, and we dynamically render views of the information. My expectation for things like a Pro-E or a CAD drawing is that CAD operator needs to know what their starting point is. From GENESYS, we're going to provide them with that starting point. What materials can and cannot be used, what their size limitations are and are not, what their power consumptions are. So in that regard, it's not a productized interface, There are ways we can get the information massaged so that it can be brought in terms of that specific design package. But if the question is it productized? No. Could it be productized? Absolutely.
Thanks, Fran. That wraps up the final Q&A for today's presentation. I apologize if we didn't get to your question. We will contact you directly to ensure that it has been answered. If you have other questions or comments for Fran, please don't hesitate to send him an email. Or you can post your questions and comments on our LinkedIn group page. Just visit linkedin.com and search for Vitec Corporation. Thank you for attending today's webinar. Our next webinar will be the third and final webinar in the Getting Practical with MBSE series, Ensuring Design Integrity Through Executable Behavior Architectures and Parametric Constraint Analysis with Ron Kratzky. That's next Thursday, June 22nd at 1 p.m. Do note that time change. The registration link is available on our webinars page. Remember that at the conclusion of this webinar, a survey will open on your screen. Please take a moment to give us feedback on today's presentation or on what topics you'd like to see covered in future webinars. Once again, thank you for joining us and have a wonderful day.